Good morning, everyone, and welcome to the WaPOR Hackathon. We're very excited to have you all joining us today and for the rest of the week. My name is Lauren Zielinski, and I'm a project assistant in the Water Accounting and Water Productivity Group at IHE Delft, and I'll be co-hosting the live sessions this week, along with my colleague, Karen Bremer.
Hello, my name is Niene Boeijen, and I'm a water management data analyst at Meta. I work most of my time on water productivity related projects, and I'm really looking forward to go with you through this week.
So this hackathon is being put on by the WaterPIP project, which stands for Water Productivity Improvement in Practice. We are a consortium of knowledge institutes based in the Netherlands with the goal of improving water productivity in the agricultural sector using WaPOR data. The partners implementing this hackathon are IHE Delft Institute for Water Education, Meta Research, and Wageningen University and Research, with active support from FAO and ELIEF and financial support from the Ministry of Foreign Affairs of the Netherlands through the IHE Delft Partnership Program for Water and Development. We're very excited to be hosting this hackathon today because it is an opportunity for us to actively work together with people from around the world to achieve better water management and improved water productivity.
So we have a great opening session for you today, with a short introduction to the hackathon, a great keynote speakers, which you can see already here, and a bit of the different themes that you will be working on. After this opening session, you will go to your teams. Most of you have joined the teams individually. Some are joined as a team, and others, they don't know each other, but you will get to know each other. And we hope you will have a good week together and maybe keep seeing each other for a longer time. But first, we would really like to kick off this hackathon by having Dr. Charlotte Fraiture give us a few welcoming words. Charlotte is the Vice Director of IHE Delft Institute for Water Education, as well as a Professor of Hydraulic Engineering for Land and Water Developments. Charlotte, it's a pleasure to have you here.
Thank you. Dear hackathon's participants, distinguished speakers, and everybody following this live stream, wherever you are. As Karen introduced me, my name is Charlotte de Fraiture, and I'm the Vice Rector at IHE Delft, and that's the Institute for Water Education. I'm also a professor in the Land and Water Development, and I have a background in agricultural water management. On behalf of the hackathon team, it gives me really a great pleasure, and it's my honor to welcome you all to the WaPOR Hackathon from database to application. So during my career, I had the opportunity to work on the improvement of agriculture water management. I learned many things, but 2 points I would like to stress here. First, the projects and research that I worked on make me really aware of the pressing global issues with regards to agriculture, food, and water management. As we all know, as water becomes scarcer and more polluted, and as climate extremes become more common, we really need to improve agricultural water management. It's really essential. I've seen resilience, creativity, resourcefulness of people in terms of coping with and adapting to challenging situations. We can produce more food with less water, and yes, we can increase the amount of water that reaches the field, and hopefully we can do it without further degrading our natural environment and negatively impacting livelihoods. But, and that brings me to my second point I would like to emphasize, it really needs dedicated people to convert problems to solutions. And people who can generate ideas, concepts, on-the-ground results, in short, people like you. At IHE Delft, we encourage our students to tackle the complex challenges that we face today using creativity and teamwork. Teamwork takes a diverse team of enthusiastic people of different backgrounds in cultures and professional backgrounds. So my advice to you, hackathon participants, is to utilize the unique opportunity and the unique perspectives of each one of you that each one of you brings to our team, to your team, and to think outside the box, to not be afraid to learn something new and focus on how the work of a few could improve the lives of many. I'm really thrilled to see that there's over 200 of you that have decided to join this hackathon. And I'm very confident that together with your hackathon team and all the expertise available, you will be able to show your resourcefulness and creativity and to solve the challenges at hand. So to all the participants, I would like to say, be sure that you are open to listen and learn and share and be heard, and to fully commit to seeing how far you can, how far you can come with your great ideas. So, on behalf of all, and in particular the hackathon team, enjoy and good luck to all. Thank you.
Thank you, Charlotte, for your inspiring words, and we look forward to tackling the challenges that you've laid out before us. Before we begin our keynote speakers, I would like to say a few numbers about the hackathon. So the first number is 250. We have over 250 registered participants for this hackathon, and we're so thrilled that you're all here. I know some people signed up individually saying there was a team supporting them, so there might be even more. And these participants are now being organized into 42 teams, each of which will be putting all of their effort and creativity into this challenge. These 42 teams will have 7 days to develop a concept and make a video pitch for our jury. And these concepts will address 4 different thematic challenges where WaPOR data could be applied. Each theme will have a winner, and then these winning teams will have 2 more weeks to develop a prototype. But in the end, there will only be 1 overall winning team. And this winning team will receive 1,000 euros to put towards further development of their prototype. I think those are some pretty impressive numbers. So we're very happy that you're all here and working on this with us. And I hope this also gives you a general idea of how this hackathon will work. And to get more specific information, we encourage the participants who are joining us to go into the hackathon platform and look around to take a look at the schedule. And for our guests, you can go to our hackathon webpage, waterproductivity.org, where we'll be posting regular updates and videos to keep you involved as well. And with that, I will leave it to the professionals to tell you more details about the purpose and potential of this hackathon.
Thank you for that explanation, Lauren. Our first keynote speaker is Livia Peiser, who will introduce WaPOR. Livia is a technical officer in the Land and Water Division of the FAO, and she applies spatial data and remote sensing to water resource assessments, in particularly in relation to agricultural water use. She currently focuses on monitoring water productivity through remote sensing through the FAO WaPOR database, which you'll also be working with. She's been working with the FAO and other UN agencies for the last 15 years, applying spatial analysis to food security, water, and agriculture. Livia, the floor is yours.
Thank you, Karin. Let me share my screen. First, I must say that I'm very happy to join you in opening this thrilling hackathon, and I would just now would like to provide you some background on why we think it is important to monitor water productivity and how we do it with WaPOR. So I would start by reflecting on a couple of figures that were already mentioned by Charlotte. Thanks for those inspiring words. I'll just provide 2 figures that explain that. So on one hand, we know that for the 4th year in a row, the number of undernourished people in the world is on the rise again, despite all our efforts. And much of this increase can be attributed to conflicts and climate-related shocks. And at the same time, more than 2 billion people live in countries experiencing water scarcity. And water and agriculture relate these 2 figures in different ways. On one hand, of course, agriculture is the main water using sector. It accounts for about 70% of freshwater withdrawals. And on the other hand, water is key in agriculture to build farming system that can survive better, that can be resilient to these climate shocks. So in a nutshell, we need to use water in agriculture in smarter ways. And I think that's why we're here today. And as we heard, so we need to be able to produce more food with less water. And that's why water productivity is an indicator that's became relevant in the last decades, because it is able to capture at the same time the agricultural production and the water that goes into that production. So that's how we define water productivity in agriculture. There's different ways for measuring it, but the way we use it here is measuring the output in kilograms per hectare, so in yield or biomass production per unit of water that is consumed, evapotranspired, to produce that output. And satellites really help us in monitoring this over time and over space, because it's a complex task to measure water productivity on the ground. And so satellites can help us providing an assessment that, of course, then needs to be interpreted with real field experience. But with the satellite technologies, we can really monitor what we do with WaPOR from 2009 to date over a continent, and we'll see that this is also expanding. So that's how it works, basically. In a short, we take data from remote sensing and translate it into key water and agriculture variables like biomass, evaporation, and land use, and so on. And then that is packaged, let's say, into water productivity and water accounting indicators. We don't do that alone, of course. There's a big group of people behind that. This is all done thanks to the support of the government of the Netherlands, but in collaboration with key international partners like IHE Delft, IMI, and a consortium of public and private entities that are behind the data production. What we cover, this table, this figure here, provides a summary of the data we have. I'm sure you will have the opportunity to learn this by heart in the next weeks, but the overview is that we provide data for the whole of Africa and the Near East at 250-meter resolution. So we have three different levels of resolution, and because we believe that each challenge has its own data requirements. So at continental level, we publish data at 250-meter resolution. Then for 21 countries and selected river basins, we publish data at 100-meter resolution. And then for 8 pilot areas that you see in those black spots on the map, we publish data at 30-meter resolution. And those data are mostly decadal in time step, while reference ET and precipitation are daily. This is how the data comes in the portal, in the WaPOR portal. But you will see that there's other ways, of course, of accessing the data. So this map is the map of the continental level water productivity. Then this is how it looks at the 100-meter resolution. This is a close-up of the Gezira scheme in Sudan. That's the largest, one of the largest irrigation system in sub-Saharan Africa. And with this level of detail, we can already see the spatial variation in an irrigation system. You can see that, for example, those darker green spots on the right of the map are commercial farming. That's where I think it's mainly sugarcane, where the water productivity is higher, while in the other parts of the scheme, the fields are, so where it's green, it's more than 2 kilograms of biomass per cubic meter of water consumed, while in other areas it's not so performing. So with this type of information, you can already start planning your intervention or targeting areas that with water productivity gaps. If we go to an example of 30-meter resolution data, this is from the Bekaa Valley in Lebanon. Here we can see both the larger fields, but also the smaller fields. And this is the type of detail that we need to go into agronomic advices and to be able to compare crop water productivity, because at this level of detail, we can also produce crop maps to distinguish the different crops and associate water productivity to specific crops. We published the data in different ways. First of all, let me say that all the methodology and algorithms are available on the website. The data and metadata are available either on the portal that I showed you, but also through APIs, and that's of course very important for hackers like you. And I will just mention a couple of key points from the methodology. This flowchart is rather complex, but it gives you I think the idea is that the data are very much, the different layers are very much interconnected, and it's good to be aware of this interconnectedness when you use this data. So please keep a version of the methodology document at hand when you design your applications, because I think it's important to understand what are the dependencies. At the same time, just 2 words on the key methodologies behind the data. So to calculate the evapotranspiration, the water consumption, we use an energy balance approach. That means that through the satellite, we can assess how much solar energy reaches the surface, how much of that goes into heating the air or on the surface, and it is reflected in the atmosphere. And what is left is the energy available for evapotranspiration processes. And in particular, in WaPOR, we do that based on a slightly modified version of ET-Look that accounts separately for evaporation and transpiration. So that's for calculating water consumption. To calculate the biomass, we rely on a model that is based on light use efficiency. So again, the solar energy is translated into photosynthetical processes, and then we can estimate the biomass production. So now we'll move to showing just a few examples of application of how people have been using our data. And this first example is from the Office du Niger in Sudan. And it's an area that is not so easy to access these days, unfortunately. And when we discussed with the authorities in the Office du Niger, they asked us to include in the pilot area this rectangular shape that you see on the bottom part of the map. And that's where, if you see, starting from 2014, from the moving line in the chart, the evapotranspiration picks up. And that's because they allocated that land to private company for sugarcane plantation, and they were not able to know how much water this would take from the system. Well, not at least not continuously. And so that's why we included that in the pilot area. And now with this information, we can not only see that it is growing, but also have some figures of how much water that translates to, how much water consumption that translates to. Another type of application, I'm now going through examples that use different data sets so that you can have a broader idea. This is done using, for example, the continental level data. So that's a type of data that can be used, for example, to monitoring drought over a continent or a large region. And in this example, we looked at the impact of the drought in 2019 over agricultural production in Somalia. So this map, this red circle there, shows an important cereal producing area in Somalia, and this was the map of NPP in May 2018. So May is the start of the main cereal producing season. And 1 year later, in 2019, it was much drier. So we just took from that circle, we just plotted the biomass development for different years and compared them over a chart. And in May 2019, we could already see that season was really performing worse than other season, in the same time period, and particularly even lower than 2011. Sorry, it was a very bad drought year. So we also compared that against FAO data, and we could estimate with large numbers, of course, but we could have an idea what could be the expected reduction in agricultural production. And I think this and this was unfortunately confirmed a few months later. So this is not to say that with WaPOR we can have a full packaged, full-fledged early warning system, because in FAO, for example, we have real early warning system that also take into account food stocks and prices, and it's more complicated than that. But the idea is that with WaPOR data, you can in very few clicks get an idea what type of impact is a drought having on the agricultural production early on during the season. Another typical example, unfortunately, is that this data can also be used to monitor the impact of conflicts on, for example, irrigation infrastructure, or how irrigation is working on the ground. So in Syria, we work with the FAO office there to monitor the damages due to the conflict in some irrigation districts. The point I would like to make here is that this is it. I mean, the information you get from satellite is very useful, but you always also need some local knowledge or understanding of what is really happening on the ground. Because looking at the data, we were also we would get some false positive signals. For example, areas that would start where evapotranspiration was growing, and one could think that irrigation was resuming comparably to pre-conflict area. But in reality, this was due, for example, to weeds or farmers accessing shallow aquifers that are not sustainable because of salinity issues. So there's a number of reasons that you would need to understand to be able to interpret the data that come from satellite. But nevertheless, this information can help you monitoring not only the damage, but also in this case, the chart here shows that the sectors of the irrigation system in which, for example, FAO provided support with rehabilitation of pumping stations were recovering faster, of course, and we could monitor the extent of this recovery. But this, again, was done in collaboration with local experts. So that's why capacity development is a key component in this program. Another example I wanted to make is about, again, monitoring performance of irrigation systems. But this example here is from Ethiopia, from the Koga scheme, where another pilot area where IMI conducted capacity development activities with farmers to increase water productivity, because as you can see from the maps, there's a huge variation of water productivity in the scheme, and there's typical head and tail trends whereby irrigation performance is better closer to the head of the system, but also they could identify spots of water productivity, of gaps in water productivity, and work on those. But I think the interesting thing in this example is the technology that was used. So we can, of course, translate the data and display them on smartphones and build applications, but smartphones are not necessarily the best way. In this case, farmers were not, the farming community was not using smartphones extensively. So the best approach was instead using less, let's say, a low-cost technologies like a soil moisture detector, and use that to do capacity development with farmers to understand where it was better to stop irrigating, because in that particular case, the problem is more about over-irrigation that, of course, negatively affects not only the yield, but also the water available downstream. So technologies needs to be locally relevant. That's the other bottom line. So in one situation, it could be a simpler technology, simpler in the sense that it doesn't rely on ICT technologies, but in other ways, it can be, of course, smartphone applications like the one they developed in Lebanon to provide advisory services to farmers. And I think you will hear more about this one. to move towards the end of this, just like to stress that it is important to understand the quality of the data you're using. So not only in terms of resolution, we saw that, of course, you can't be designing farmer advisory services using 250 meter resolution data, at least not, and you can use some of that, but then you really need a higher resolution data to go to a detail that makes sense at field level. But you can use the 250 meters data for other type of applications, as we saw. And that's so understanding the different types of data you have, but also understanding the quality. And that's why we also invest a lot in quality assessment. There's one report that was done 2 years ago. Another one is coming hopefully in the next few weeks. But there are also many articles that describe the accuracy of this data. So it's important to cross-check all this and understand the data you're using and what's the quality you can expect from that. Then to close, I would just like to mention that with WaPOR, we're expanding in time and space, and we are trying to get to be more accurate by integrating higher resolution data like the Sentinel program. Higher resolution not only spatially, but in this case particularly temporally, because that's another key parameter. So with a higher temporal resolution, we can better, for example, estimate water productivity in, for example, cloudy areas. And another thing we are very excited about is that last Friday, the industry contract was signed between Copernicus and the partners that will be working on developing the land surface temperature monitoring mission for Copernicus. So in the next few years, I don't know, it's not happening tomorrow, but in a horizon of around 5, I don't know how many years, but a new satellite will come that will measure land surface temperature with a higher resolution, and that will really change the quality of the evapotranspiration assessment. So we're very excited about it. With that, I would conclude. I really would like to wish you the best success in this exciting initiative, and I'm sure that with your smart ideas, you will really make you will really join us in building a water and food secure world. So thank you for that, and best of luck.
Great. Thank you, Livia, for, let me turn my camera back on. There we go. Thank you, Livia, for sharing with us about the WaPOR portal and the latest developments. I think it's easy to see the great potential of the WaPOR database in many different sectors related to water management and also within our hackathon. So participants start thinking about how we can use these different data sets. And I would like to introduce our next speaker. He's here to address a very simple question. What is hacking? For many of us, this is our first hackathon, so this is a question we may be very curious about. Dr. Hans van der Kwast holds a master degree and PhD from Utrecht University in the fields of remote sensing and GIS. He has worked at the Flemish Institute for Technological Research in Belgium as a researcher in spatial dynamical environmental modeling. And since April 2012, he has been working as a lecturer in eco-hydrological modeling at IHE Delft, where he teaches open source GIS and modeling and is involved in both capacity development and research projects. So Hans, the floor is yours.
Thanks, Lauren. I'm sharing my screen. There we go. So thanks for the introduction. I'm also a board member of the QGIS user group in the Netherlands, and I will give you some examples about how in the QGIS community we also deal with hackathons, and also the difference between the traditional hackathons face-to-face and what we do now online. So it's really for beginners who never did a hackathon. So what's a hackathon? Well, there are different names that you will see. There's Hackfest, that's what we use in the QGIS community. Hacktoberfest, if it's in October. Essentially, it comes from the software development. where you have a sprint with a group of people to improve the software. But it moved a bit away from that it can also be done for other things. But essentially, in the original definition, you bring together computer programmers, but also graphic designers, people who have experience with user interaction design, but also people from the domain and project managers, and all come in a collaborative environment to share their knowledge and to come up with new things that are useful for a certain goal. And traditionally, the goal was to create functioning software or hardware at the end of such an event. Now, hackathons can have a specific subject, and there's different choices if you organize a hackathon. So this one has a very clear subject. It's about developing tools using data and the API from WaPOR, the things that Livia just has shown, and to come up really with good new things you can do with that are useful for different stakeholders. It can also be for a particular platform, a specific mobile app or a web page, or for a certain cause or purpose, maybe help the government with open data, or NASA or ESA, or something in disaster management. And here you see an example from WaG, an organization in the Netherlands. They recently organized, also due to COVID, an online hackathon about the green city and bringing people together. And we learned a lot from their experiences. And we're very thankful for them to share that with us for this hackathon. You can also do hackathons for a specific target group. Maybe you want to bring teenagers together, or students, or a group of women. So there are different choices there. Here we are very inclusive, and we want anybody in the world to join and get a good mix of different stakeholders. You can also use hackathons to promote product innovation. And I don't know if you know, but Facebook's like button came out of a hackathon. And then back to the original purpose is to improve specific software, for example, QGIS. It's also good to look at what is not a hackathon, so we have our expectations right. It's not a social gathering only. Sometimes with hackathons, people come in without really contributing to the development or to the goals, and then it's people who are contributing to it feel more like it's a zoo where people come look at them to work. That's not the best way to deal with hackathons. There are social gatherings, they have other purposes, I'll come to that. It's also not a course. It's not something you do for your studies. And as a lecturer, I can show you this different levels from Bloom's taxonomy that we apply in education. And a hackathon is really at the top of the pyramid. After learning all the concepts and doing all your school and university work, you will hopefully end up at this top of the pyramid. And I hope all participants are at that stage to produce new and original work, to connect dots, to design, assemble, to investigate, and be very creative. And that's what we really ask from you in such a hackathon. Of course, there are still things you learn, but you learn it from each other and not in a scholarly style. Now, how do we get this innovative environment? Well, we need to be able to connect the dots, so there need to be building blocks available, such as the APIs from WaPOR, but also from other tools that you can use, or other data sources. You need teamwork. That's very important, and we'll be looking especially at that. Because you can only make something great if you have a good mix of people who are collaboratively working on something. You need inspiration, an inspiring environment, and an enabling environment. And that's, of course, tricky if you move from face-to-face to online. So I'm going to give you a quick example about the QGIS Hackfests. Now, they are called contributor meetings because there are more ways than just contributing by coding. You can also work on improving the documentation or working on other aspects of the project. It's often a pre or post-conference event. So if it's a post-conference event, you can even get inspired by sessions at a conference. It can also be standalone. And we have seen hackathons that are within 24 hours, you need to deliver something. Personally, I'm not a big fan of those kind of code sprints in 24 hours because I think your brain gets overloaded and you need to have really Also these social moments where you sit together with food and drinks and can discuss and then come up with new things, and the next day you can work further on it. So a few days concept, personally, I find that more inspiring. The format that we use with QGIS is the unconference, which means no schedule. There's a whiteboard and with times on it, and you can just put names there and themes that you want to discuss or work on, and then it just goes. And this is how it looks like. This was in A Coruña in 2018, I think. And tasks are then to fix bugs of the program, do translations, work on documentation or organizational aspects. But there are many more things you can work on. And help each other and find each other, use each other's qualities. And there needs to be facilitation, there needs to be food and drinks, and social activities in the evening. And this is a nice picture from Hackfest in Nodebo in Denmark, organized by Lene Fischer. And there we always go in the evening in this block hut where we have drinks and play traditional Danish games. Now, how do you get inspired and how do you connect these dots? Well, I'm going to speak about my own experience. I followed this workshop by Kurt Menke, my co-author of the book QGIS for Hydrological Applications. And we were there learning about how to use the new mesh functionality to make these animations. At the end of the workshop, we could make this visualization with the arrows. And I thought, hey, with hydrological applications, we have this problem that the flow direction in this desktop GIS software is not really visualized in a nice way. How do I get those arrows for the flow direction? And if this already exists, then probably that's not a big step because it uses the Crayfish plugin made by Lutra Consulting. And during that Hackfest, I met the programmers of the Crayfish plugin, Radek and Peter, and they were happy to help me further with that idea to make a kind of conversion tool where we can style the flow direction from Saga with these arrows, and that's what you see here. So you can choose the flow direction from Saga, export it to the mesh format, and then in the end you get this result. For the sake of time, because it took a bit longer, I'm going to skip here this animation, but you'll find it on my YouTube channel. Now, that's, of course, nice if you're in a face-to-face setting. But if you need to go online, then how do you create this environment? And how do you keep people cooperating while they are not next to each other and can't have drinks and food together? That's indeed a challenge. So we are pioneers. There are not so many examples yet to look at. So this is one big experiment. And you are part of that. But of course, we invited creative people like you, so that shouldn't be an issue. It needs more planning and structuring in advance. So therefore, we need to give a structure. We cannot do completely unconference. But the big advantage is that we can achieve worldwide participation. I don't know how many different countries are participating here at the moment in the live stream, but we see that you're from many different places. We also need to define different roles. And you need to work on themes. And there is a schedule. Now that can hamper the creativity, you would say, but in the online setting, you need to do these things. And also we need to define the teams, which we did. So it's not completely an unconference format, but we still hope it gives this dynamics of creativity to boost innovation. So we defined what categories of participants, basically very wide and different roles. And for making the teams, because we cannot know all the 250 plus participants, you filled in an intake form, and based on that, we made the groups, looking also at different expertise and interests, so to make it a bit mixed. And then you also, if you do it online, you need a collaboration platform. With the QGIS, we of course work like many programmers with GitHub, so the code is already in online tools. But during the hackathons, we work face-to-face. But now we also move with QGIS to online, and we have different channels that we communicate. And every last Friday of the month, there's an online session. But that's the Friday open days that we have the end of the month. So feel free to join. But here for this hackathon, we designed this platform, and we really hope it's functional for you, and you find all the information and ways to meet in there. So this is the end of my short presentation. I hope you get a bit inspired and get a bit of background about hackathons, and I wish you happy hacking.
Yes, I'm there. Thank you very much, Hans, for this explanation on what hacking is, what it is not, and how this online hackathon differs from online hackathons. But we hope you will get the same spirit, the same team spirit, finding creativity, helping each other out, and also have fun while hacking. So up next, we have a short presentation video, which has been pre-recorded by the creators of Plant Village. This is an NGO that provides solutions to smallholders and extension workers by leveraging advances in artificial intelligence, mobile phones, drones, satellites, and nanotechnology. Because of the time, we will just share a short part of the video, 5 minutes or so, but it is a very nice video, and I would very strongly encourage you all to watch it to get inspired by it and to see how a mobile phone can really do so much for farmers and combining different data sets and different knowledges. The video will be online on both the website and on the platform. So yeah, there you can check it out. Hans, can you please start the video for us?
Hello, everybody, and welcome to this introduction to the hackathon regarding Plant Village and its integration with WaPOR. My name is David Hughes. I'm an associate professor here at entomology and biology at the Pennsylvania State University, and I'm joined by colleagues also from Penn State. And here at Penn State, we've set up a system a number of years ago called Plant Village, which is to bring the power of a land-grant agricultural university into the hands of farmers around the world. So we'll hear from our colleagues throughout the talk when they begin their part of the presentation. But very briefly, we have Annalise Keys, who's the executive director of Plant Village. We have Derek Moore, who is a data analyst and IT architect at the university, and we have Dr. Fei Zhang, who is a GIS expert also at Plant Village at Penn State. So what you're looking at here in this photograph are two smallholder farmers in Africa, both incidentally called Rosalind. One of the background is Rosalind Akochi, who is one of our lead farmers, and you can see that she is holding a smartphone. And so what Plant Village is trying to do is to bring the power of cloud computing, artificial intelligence, and integrated systems with data such as the one we get from WaPOR into the hands of smallholder farmers like Rosalind. And we can see here again, this is also Rosalind. She's standing beside Emiliana, who's a smallholder farmer in Kenya. And the problem that both Rosalind and Emiliana have is a lack of access to experts who can help them make clear and accurate decisions on the problems that they face in the farm. And the reason that they lack access is because there's just not enough experts on the continent of Africa to help people grow enough food. And so, as we all know, artificial intelligence has this ability to do things that only human experts were able to do. And in this case, in these videos, you can see that AI is running a computer vision model inside the phone to diagnose healthy versus unhealthy plants. The first video is cassava mosaic disease, which is this crinkly yellowing of the leaves. And the other image is fall armyworm. And these models work inside the phone offline, thereby providing smallholder farmers like Rosalind an ability to get an accurate diagnosis. And perhaps more importantly, to empower farmers like Rosalind to be agents of change in their community. Rosalind is a very well-respected community member, and she oversees many activities in her community, and she has a strong desire to help other farmers and share knowledge. And now that she has a smartphone from Plant Village running these offline convolutional neural networks inside the phone for computer vision tasks, then she can go around and help her neighbors, and she does a phenomenally good job of that. So here again is the original picture. And so here we're showing how Rosalind is not getting a diagnosis of a pest disease using computer vision, but is actually pulling down data from the WaPOR system. So WaPOR is this tool which integrates MODIS and Landsat observations, as well as a range of models which have already been developed by agricultural scientists to look at things like above ground biomass or evapotranspiration of the system. And she's able to stand in a field in Western Kenya and get observations every 10 years into her phone. And so why is this important? Well, primarily it's important because of climate change and the unexpected disasters that occur around this. So in 2019, an example of those disasters was Cyclone Kenneth, which hit Mozambique on the 14th of March, and Idea, which hit on the 25th of April. Both were the largest ever cyclones that hit East Africa. And as they hit Mozambique, they pulled moisture out of the atmosphere in Kenya and Uganda. And the effect of this is that the growth of the crops, which should have gone upwards here in March, didn't, because it was just too dry. And many of the farmers in the plant village community failed to be able to grow adequately in that season, and a number of them had 2 and sometimes even 3 failures of these seeds to germinate. Now, what we're trying to do is leverage machine learning, and this is some work that Derek Moore, who we'll hear about momentarily, has done. And so just some simple out-of-the-box tools like XGBoost, looking at this data at the time, shows that with enough training data, we can achieve accuracies which are quite high in determining what the next step in this data stream is going to be. So the data is coming in from WaPOR every 10 days. And so we could see with roughly 95% accuracy on the holdout data, how well we could have predicted this. So rather than farmers experiencing the stress, we have the ability through spatial temporal machine learning to use predictive analytics to say a stress is coming. And of course, that is a much better proposition than just experiential knowledge. WaPOR is an extremely well-developed investment, primarily by the Dutch government, into UN-FAO in order to leverage tools from Earth observations to enable better water use on the continent of Africa and the Middle East. Originally intended for irrigation systems, but the way the Plant Village looks at this is that 94% of African farmers, and there's hundreds of millions of those, 94% of them rely upon rain-fed systems. So they plant the seed and they wait for it to rain. And under climate change, all bets are off. You can't use the past as an accurate guide of the future. Everything is hectic and really changed. So we want to use the power of WaPOR to enable the majority case in Africa, smallholder farmers who are rain-fed, to be able to better prepare themselves for the stresses and strains that climate change is producing.
So I would like to thank the Plant Village team and for producing this video. Like we said, it's just a small introduction. So please go to the hackathon platform under the inspiration tab to watch the full video, or you can go to waterproductivity.org and we'll also share the video there. Our final keynote speaker is a full stack web map developer with a creative focus going from data analysis to visualization on the web. Niene Boeijen's web cartography overlays the world of GIS, web technology, and design. She has a master's degree in geographic information science from Wageningen University, worked for 4 years at WebMapper, and this year she started working as a freelancer. So today she will share her thoughts on the potential of unlocking hidden numbers using web mapping. So Niene, it's a pleasure to have you here.
Thank you so much. Thank you for this introduction. Yeah, let me share my screen to start with. There we go. And the camera. So thank you, Lauren, for the introduction. Welcome, everybody. My name is Niene Boeijen. And just 2 weeks ago, the board approached me to do this keynote speech. And as you can see, my keynote speech doesn't really have a title yet, because I had a really hard time pinning down what it was that I have to tell you today. So the board asked me to tell you something about UX, design and maps and how to make beautiful maps. They asked me, hey, Niene, how do you do this? And making a good web map application is actually a combination of so much things. It's about doing the right data analysis. It can be about cartography. It can be about design. It has to be about the interactive design and user interface design. And eventually it's also about programming and developing the front end visualization. So it's a lot. And a keynote speech is actually really short. I don't have that much time to tell you everything that there is even possible to tell about web cartography. And then I also realized that the WaPOR database in this hackathon is about remote sensing data. And I don't really work with remote sensing data anymore. So I mainly focus on doing web cartography and focusing on making these front-end data visualizations based on GIS data. So I had a really hard time to think about what it could possibly be that I can share with you today that can help you during this hackathon. So as Lauren already said, I did study some remote sensing in my studies, and I even studied international land and water management. So the topics and the themes that you're talking about today and the data at WaPOR is about are not that strange to me. But it has been a long time ago that I worked with remote sensing data and that I worked with water data, for example. So in order to give you this talk and to give you a good story, I had to start doing a little research. And I started my research with looking at the WaPOR hackathon website. That's where I started, of course. And when we look at this hackathon, the board defined a theme for this hackathon. And the theme is from database to application. And that actually triggered me. That got me started thinking. And I was thinking like, hold on, wait. Why do we actually immediately jump to the conclusion that we're going to build something of an application? To me, an application is a technical solution. It's the technical execution of something that is something that we apply. That's the technology. It's not where we should start off. There is so much data available in the database. And if you look at the 4 themes that are defined for this hackathon, they underline a wide range of problems that you can probably solve with the data in this database. It could be about water management. It could be about helping local farmers, identifying environmental issues, or monitoring change. And as we heard before also, there is so much possible problems and solutions that you can find in this data. And this illustrates that that this hackathon is not about building an application or a technical solution. It's about the stories that we want to communicate, the stories that we want to communicate about problems and possible solutions. It's about telling a good story about the data. And the technology is not the goal. The technology is something that we apply. And when we look at the amount of data that we have available, we need to do something with this data in order to make it into information. And then we have to communicate this information to our target audiences in order to create knowledge and wisdom. Because giving people just raw data doesn't provide an insight. We have to turn this data into something which they can use and which we create insight and we can increase knowledge. So I actually want to propose a slightly different theme for this hackathon, at least for this talk. And I want to challenge you to this week to not focus to go from database to an application, but to see if we can go from database to story. And why do I find this so important? I see a lot of applications out there on the web, a lot of GIS applications also, which are just about putting the data out there. And if you put all the possible data that you have into one application, it gets really, really clouded. And I just wanted to show you and give you this example. So this is a basic S3 web map, and this is of a province in the Netherlands. It's about solar energy, and the only thing that tells me it's about solar energy is maybe the title. But then there is a lot of data available, and I can just randomly click on stuff and it adds to the map, and it just clutters the whole map with data and information. And as you can see, there is also a lot of data sets that not really have a clear legend, and it just gets cluttered. This application fails, in my opinion, because it's not telling us a story. It doesn't have a clear goal. It's just throwing a big bucket of information to our audiences and then hoping that they can understand, that they can decode this data into something that is useful for them. So let's be careful. The WaPOR database contains a lot of data. And I think remote sensing data is really a type of big data. It updates every 10 days. It covers a huge amount of surface on the Earth's surface. And we have different spatial resolutions. But the raw data in itself is not useful yet for our audiences. It has no particular significance yet. It's what we do with the data. It's how we translate our data into a story that we can translate it into knowledge for our audiences. And I think this is the real challenge for you. To create something this week that transforms this database and this data into knowledge to our target audiences. So as Hans explained, we're going to start off with exploring through the data, and you're going to use your creativity to find that story that you want to tell. And then you found that something special. You found that something that is worthwhile sharing and that you need for maybe backing up your policy decisions. You need to communicate to your policymakers, to some other industries. You want to communicate it to other authorities or maybe to a local farmer. But the thing is, to whatever goal we have and to whomever we are communicating, we're always communicating to people. And we have to think about the story that we want to tell with our data, but we also have to think about the user that is going to read our data. So on the one hand, we have our data that we have to translate with, and we call this encoding of the data. So we make it into a visual application or a technical application. And then on the other hand, we have the user that have to understand this and have to decode the information that we give to them. So I think it's really important to not only look at the data, but also to look at to whom am I telling this story? And that is the only way that we can be able to tell the right story in the right visual way. And let me just give you some examples. In my opinion, if you develop a web map, if you develop an application, the main goal is just to keep it simple. And I wanted to start with just showing you the WaPOR portal. And I hope you already all saw this portal. And I want to start with that because actually we are the target audience of this portal. This portal is aimed at us, for us to explore the database, explore all the data that is available at WaPOR, then compare the different images, and then download, then choose the data that you find interesting, and then download this data. So let's have a look at the portal. And I think the portal is fine. You get dropped into a map, and the information is clearly there, and we have a nice legend. But the goal is of this map to explore all the data that is available at WaPOR. And this is already where I find myself a little bit confused, because the goal of exploring all the data available at WaPOR is not really clear in this map. I have to click and I have to know that I have to go to a button at the bottom, which is actually really small in the view, that says layers. And that is where I can go through all the different kind of data sets that are available. And then also there is the catalog, which actually provides us with the same kind of functionality. It provides us an overview of all the data sets that is available, and we can explore and go through it. So why do we have different views and on the same kind of functionality? And then also I can click on a data set and I go into the more comparison functionality where I can compare the different images throughout time. But even here, it's not really possible for me to compare all the images to each other because there's multiple pages that show me the data throughout time. So to me, the WaPOR portal is a good way to starting off, but still it's a little bit cluttered and it doesn't really give you a clean functionality that goes with the goal. So just keep it simple. Always remember what is the goal, what is it what you want to achieve, and then reduce the complexity so that people can go through your application in small steps and get this really immediately chunks of information that they can grasp and understand. And in the WaPOR portal, we have to click a lot, and there's a lot of little small buttons that are actually the main functionality of the goal of this portal. So reduce those clicks, make things bigger that are more important. And if you reduce clicks, provide the information in a clear way, it gets much faster, it gets clearer, it gets cleaner, and it gets simpler. So with everything that you add to an application, ask yourself, what is the goal? What problem does this solve? So let me give you another example. And I don't work in the remote sensing field. So I got this application from through a colleague of mine, which I asked for some advice. And she gave me this website, the Remote Pixel. And this website, I think, is also aimed at finding and downloading remote sensing data. So you want to explore what data is available, you want to compare it, and eventually you want to choose that one image that you want to download. So when you go to this website, it actually starts out with a map that contains a grid. And then if you choose one of the grids, you can go to that image, and it provides you a really clear overview of all the images that are available on that grid. And then you can choose the one, and you can download it on the left by clicking on one of the bands that is available. And I think this is just great. We have a map for exploring what data is available. Then we choose the area that we want to have data on, and then we can really easily compare all the data that is available just in one page, going through all these little chunks of information. It's just a 3-step: explore, compare, and download the data. Of course, these were just some applications that have a really clear goal of exploring and downloading data. But an application could also have a goal to give you the data and let the user be able to explore and analyze a lot of data. And this can become really confusing a lot, because the pitfall is that I see a lot of applications out there that actually try to mimic what GIS software does on our desktop. So I wanted to show you this application, which I totally love, and I think is a really, really good example of a complicated dashboard, but giving you really clear information. And let me just go to that one. So this is the Opportunity Atlas, and actually it's about social data in the United States. And when you open up this map, you first get an overview of the whole of the United States. And there is just one data set that is active on the left-hand side. There is more data that I can find there, but they start out just showing us one data set. On the right top, there is a little panel showing us a filtering function on the population data. So instead of looking at a complete population, they give us the ability to filter out our own view. So I can switch, for example, from gender all to only female people in the data set. Then what I also really love about this is that if you zoom in, the spatial aggregation gets more detail. And I hope it works with my internet speed. Yeah, there we go. So when I zoom in, the aggregation level gets smaller and smaller. So by zooming in, we give the user the ability to explore more detail of our data that we provide. And then if I want to have more data, I can go click on the left. And there is so much data available here of which I can choose and switch through. And I think that this is a really complicated application, but it's really clear because they really organize the functionality and they organize what's in there. And then also what I really loved about this one, and it's not working, I think my internet is just too slow. Yeah, there we go, is that they give the possibility to look at the distribution of the data. So instead of just providing us a map with data, they also provide us with some extra information about the data set, and you can look at distributions. And why does this work so well? Is because they structure and organize everything really, really well. And they also make use of this thing that I call like layering the complexity. So in order to keep it simple, you start out with this overview first. And as you saw, they just start out with giving you one data set to look at. Then on the user request, we can zoom in and we can filter all this data. And even on demand, I can ask for more data that is in there and explore the data at my own pace. So they really layer the complexity in this application very well. Another way to do this is, and restrict maybe the freedom that a user has, is give a more linear story. And this is also something that somebody gave a tip to me about. It's a Geofolio, and it's a website where you can ask for like a data sheet on a specific area. And then you get this really linear data sheet. And they start out with an introduction, and they give you an overview, like, hey, this is our area of interest. This is what we're going to look at. And our area of interest is located somewhere in Spain and Portugal. And then they zoom in and they give you actually like 3 overview maps. So we can really see where our area of interest is located. And then they just continue with giving you some information about land cover, and giving you information about topography, etc., etc. And this is just really a linear story, providing you with really organized steps of information. There's not much information on demand, so I can zoom in a little bit on the maps that are in this application. The interactivity is really limited. But I think it provides a really clear story and a good linear story. And what I also love about this application is that they provide us with a map of information, but they also provide us with accompanying graphs that show us the same information, but in a different visual way, to highlight the different aspects of the data in there. And this giving an overview and getting data on demand makes it also possible to incorporate a lot of different aspects about this data into our application. So I also ran across this one, and I really, really love this. It's a simple viewer just showing you one data set, but then we can toggle this view uncertainty layer on and off, which gives us some information about the uncertainty of the data that they provide. And I just love this. This is a really simple button that provides us to understand the information that we see much clearer, much better. So as we saw before, providing information about the data set in the form of distributions or in the form of uncertainties, or maybe just providing different views on the same kind of information, really learns us more about what the information is about and makes us understand a little bit more about information instead of just throwing the data to our user. It helps us to explain the data. So incorporate the analysis also into your data story. And explain to the user what the data is about. And maybe this might sound all really complicated. So let me give you another example on how you can quickly improve your data visualizations. And actually, it can be really, really simple. So here we're looking at a map, and I ran across this in a news story in the Netherlands. And you see just a map with locations in the Netherlands. So the map is really easy, and we just have dots on the map. But this map gives us locations about projects of building new houses in the Netherlands. And this map could have been about any kind of locations in the Netherlands. But by putting the map on top of this image of a new built house, it immediately links that this map has something to do with this new built house project in the Netherlands. So if I would change this image to maybe an image of a deer, then maybe you would assume that the dots on the map would indicate locations where we had deer viewings. So putting your map together with an image is helping your audience to relate to the topic and really engage with the data that you're providing to them. And this is something that I call setting the mood. So the visual tone of your map can really help your audience to engage and understand more about the data that you're providing to them. So let me give you just another example, which I think is really easy to understand. So here we have a map which shows us data about fatal gun incidents in Wisconsin. And it's a good map. It has a clear legend. It has a clear title. And we can understand where the most gun incidents are. But this is just a simple map. And if we would take the same data, but dress it up a little bit more. So make sure that the color is coherent with the theme. Add a little image to it, like this shooting target on top of the map. We can immediately feel the impact of the data, and we can realize like, wow, this is about people that die because of gun deaths. And this helps us to engage our audience. So think about the visual language that you use, and then also think about the target audiences and how they can relate to your data. Just another example is, for example, is this satellite map. So we cannot only have to do this with images, we do this with the whole visual language that we use. And I just love the satellite map because it shows you where all the satellites are around the globe, and it's an amazing visualization. But what I love is that they use this quirky kind of typography and these big buttons with these that makes it look like we're in a rocket. It makes it look like we're in Star Wars and that we're in control of this rocket that we fly through space. And this really relates to the theme of the data that we're looking at satellites that are flying somewhere in around the Earth. So using the correct visual tone to engage our audiences is really, really strong. And that can be a power of a beautiful map. So our audiences can emotionally relate to it. And it can trigger us, and it can get us hooked to look at the data sets. So really think about the audience and how you can get them along in the story that you tell. And applying this wow factor, as I can call it, is really comes in handy to get your audience engaged, but it can sometimes also be a little bit too much. And I got this website also, the Van Borne potato farmer. And when you open up the website, it's immediately clear that we're looking at a farmer who is growing potatoes, and he does a lot with technology. But then when we scroll down, there is this weather station information going on, and you can see the numbers running and running and running. And there are so many numbers. And let me replay that for you again. And there is an animation on it. And the only thing actually that this tells me is, look at all the numbers we have. Look at the amount of data that we have. But I don't understand these numbers. I really don't know why you would have 3,000 Celsius degrees and there's no explanation in it. And there's nothing to back up what this might mean to me. It's just throwing me a lot of numbers. And that gets me wow, okay, this is a really, really technical farmer. But that's then also the only story that this tells me. And there's a hard balance on when you apply this wow factor and how you can apply it. I often also have clients that want a 3D view on the data just because it wows the authorities. And I built this application, and actually when you open it up, you start out with a 2D view, because in my opinion, a 2D visualization is way more clear than a 3D visualization, and you don't always need it. But the people that use my application really wanted a 3D visualization because they need to persuade their authorities, and they need to persuade the audiences that there is some kind of importance to the data. So I provided the ability, just with a simple toggle, to go from 2D to 3D, and just to provide the audience themselves to choose for a 3D visualization if that might help them in telling their story to their audiences. So be careful. And it's hard to find that balance between telling a functional story and telling something with the right data, and then also making a beautiful map. But it can really help to engage your audiences in that. And I hope that by giving you this information and showing you these examples, I gave you a glimpse of what it might be that can really translate a data visualization into a good data visualization. That can help us translate all this data that is available at WaPOR, so all the remote sensing data they have, into information, and then sharing that information by communicating the right story in the right visual syntax to our audiences, so that our audience can understand our information and they can turn that into knowledge for themselves. And then maybe eventually that our audience can use their knowledge and information to make wise decisions in the future. So good luck this week in turning this database into an incredible story. And a good luck with working on this incredible amount of data. And I hope that you can build something this week that really translates this database into knowledge for our target audiences. Thank you so much for your attention.
Thank you very much, Niene Boeijen, for your great presentation. I think it has challenged us all to really think about what story do we want to tell? How do we want to make it visible? How are we actually going to get across the information that we want the users to see and to understand in a good way without having too much other things going on, and have a really clear things and use also visualizations in a creative way? Thank you. I think it is very helpful for all of us in this process. And yeah, we are a little bit running out of time. I hope you participants can stick with us for a couple of minutes more. It won't be much, maybe 5 to 10 minutes. And we will just explain what will be next, how the teams will work. But first of all, I want to give a big thanks to our keynote speakers for the great presentations. Livia, Hans, Niene, and also the people from Plant Village. It has been really really nice and encouraging and inspiring. We will share also the presentations with you later on YouTube. We are recording a video and then that will be placed, but also, we hope to really post high quality versions of the presentation so you can watch it back later. So let me get back to the things starting up now. I'll quickly plug in my computer before it turns off. So you will be you are placed in teams, and after in a little bit you will get to know each other if you don't know each other, and we have set up a nice way of how you can get started and actually start working on the things. But first of all, before I get into too much detail about really what's next, how will you go about, my colleague Simon will give a short introduction again on the themes you will be working on. So Simon, the floor is yours.
Yeah, thanks, Karen. I really won't take a lot of your time. I will give a short presentation on the themes, which are actually also highlighted on the WaPOR portal that is all visible to you. I'm just going to share my screen here for you. One moment. There we are. Just switch on the camera again. There. So just a little quick introduction to the themes that we have identified in this hackathon. They were actually also briefly mentioned by Niene. So again, I was very impressed about her story, about the story, focus on the story that has to become into knowledge. We want that story to fall in line with 4 different themes that we've presented on the website. So the first one off is communication to smallholders. And why have we taken this one? Well, 500 million smallholder farmers actually are working in Africa and Asia to produce 80% of the consumed food there. Which, if you just, again, it's all about numbers. If you just let that sink in, then those are incredible amounts. So it's essential that whatever we do with regards to improving production or looking at the reducing of water, then it is them that we have to target. It is them that we have to get that story out to. Questions that you could ask within this theme to yourself, to your group, is how could WaPOR be used for smallholder farmers? How can it be used? And how can it inform decisions? So what story can we tell, can we think of telling towards smallholder farmers using that data from WaPOR? And how can it inform their decisions, so to capacitate them? The second theme that we've identified is big data for water management. Now, at scale, at national level, or at river basins, or in irrigation schemes, or in areas where water actually recharges groundwater, there's often incomplete information. What is actually happening with the water that is falling out of the air, the rain? What is water that is actually flowing through our rivers? So a lot of information is scattered, incomplete. Now, there's quite an opportunity with the remote sensing data, and particularly with the WaPOR portal there, right? It covers all countries, it covers all the area of a river basin, it's near real time. We've got data from the past 10 days, and it could really result in better choices for short and long-term management. Now, how could WaPOR be used to work at these different scales? It could help policymakers, perhaps, in making the decisions in terms of how to manage their water resources, big industries, how to anticipate what is going to happen within the area that they are working in terms of water, but also in terms of climate that is changing, river basin authorities managing water, or large irrigation schemes that are really managing the water for the productive purposes that they have. The third category is remote sensing for environmental issues. Now, we've separately identified this because besides the productive part, there's also a large part that relates to production, but also relates to a lot of other elements in terms of the environment. So there's a lot of landscape degradation going on, desertification, widespread pests. We had locust infestation the past year, which endangers all of our natural ecosystems. And because there is a lot more dependent on these natural ecosystems than only the ecosystems themselves, it's us as well, it's the livelihoods of people. We want to challenge you how WaPOR can be used for environmental issues. Just looking at rangeland management, or the monitoring of protected areas, predicting vulnerability, low costs, outbreaks, or predicting food insecurity, like the example that Livia also gave in terms of the production in Somalia and the forecasts. Last but not least, category 4 is the monitoring of the Sustainable Development Goals. I guess you've all heard about these Sustainable Development Goals. Before that, do we remember the Millennium Development Goals? Millennium Development Goals were identified in 2000 and ended in 2015. And they were actually monitored through this MDG monitor. And what I just wanted to highlight quickly is that the statistics provided on the MDG monitor were obtained from data available by national governments to the international statistics systems of the UN. And then they were adjusted for comparability. Why do I mention this? Well, these were national governments that were providing data. We've got a WaPOR portal with a lot of different data sets that could really do the same for the Sustainable Development Goals. So the Sustainable Development Goals, they're a blueprint, right, for how we want to get from 2015 to 2030. How do we envision what is going to happen? There's a lot more goals as well. We've identified 2 goals that could really be specifically focused on when looking at WaPOR. These are looking at agricultural productivity, and hence income of smallholder farmers or big farmers, ensuring sustainable food production systems, but also looking at resilient agricultural practices. So how can these practices actually continue until 2030, but obviously they're beyond. In SDG 6, we're talking about the water use part. How can water use actually and water use efficiency be improved to also serve across sectors? So not only in agriculture, but also to serve any other sector that is using water. And really protecting our water-related ecosystems. Finally, SDG 6 also shows how local communities and the participation in improving water and sanitation should be attained. And that's really one of the important things, not so much with regards to agricultural production, but with regards to the livelihoods again, and how people can sustain safe water in their homes. So that's it with regards to the themes. Back over to you.
Great, thanks, Simon. We appreciate you going over the 4 themes. As our teams begin brainstorming ideas, they will need to select one of these themes as their focus areas. And as we go through the judging process, the different themes will be judged together, and we'll have one theme winner. So this brings us to our final topic of today. What comes next? For our guests who joined us, we thank you for joining us, spending your time this morning to learn more about the hackathon and listen to our keynote speakers. And we hope you continue to join us along our journey on the waterproductivity.org website. And you can also follow us on our Twitter page. You can use the hashtag WaPOR Hackathon to track us, or you can go to the WaterPIP Project Twitter page as well. We hope you also join us in 1 week. So next Tuesday morning, our teams will present their 1-minute video pitches to our jury. And we have another set of keynote speakers set up. So I think it'll be a really nice time for you to join us and follow the process. For the participants, your work is just beginning. So your goal is to turn your ideas into a creative but concrete concept. So after this opening session ends, you will go into the hackathon platform and open your team workroom tab. And here you'll meet inside of your workroom and begin working on the mural. What is a mural, you ask? So a mural is a digital workspace for visual collaboration, and we've created one to help guide you through this creative process, through this hackathon. And what does a mural look like? Well, Karin here will show you exactly how to access it, so how to get to your team workroom and how to open your mural, and also how to communicate to your teammates through our Jitsi workroom.
Thank you, Lauren. So I will first, when you log into the platform, you will start off at a welcome page. And on this platform, there is all the information that you will need for this hackathon, or at least you can access it through that. When you go to your team workroom, you come to, oops, what's happening? Let me first quickly fix this. I'm sorry.
That happens sometimes, Karin. Just wait a few seconds and refresh the page.
Okay. We are back again. Almost. Okay. Yeah, so when you start off at the welcome page, and then when you go to the team workroom, this is the place where you and your team will meet. So you can see, like, I'm coach of several teams, but when I go to team 3, that will be what you will be seeing when you are in the team. Under index, you will see an overview of the different coaches, and each team has a coach assigned. So during the rest of this morning, you can meet together in the Jitsi room, which will be a chat room with video chat where you can communicate. You can also use the forum to communicate together, whatever works best for you. And your team coach will drop in quickly to meet up with you there. So another thing that we created to really help you with this process of brainstorming, and especially when you are all over the world, different countries, mostly of you don't know each other, is a mural. So a mural, when you click on the link, you will get, might take some time, and you will get like an opening page like this. So I will type here my name, Karin, and the visiting shrimp, and I enter as a visitor. It is not needed or not required to sign in with your account. You can just enter in as a visitor. And what you see, it's probably a bit blurry, which it is anyway, because it is a gigantic wall. And on this kind of wall where you can zoom in and out, we will guide you through the whole process of going through different, through the different steps in a hackathon. In the top, you see your team number. Here in the left top, there's an explanation with all the things that are you have to hand in by the end of the week, the deadlines, where you can find help on which things, and just some general information. So during the week, starting today with the team, you will go all the steps back and forth to your final part, which is at the bottom. That is the documentation of your concept. This program has a lot of features, and one thing you see in the bottom, that's the zoom panel and the move mode. So you can place a lot of things, and then when you move, you can maybe move other things around. So when you click on this hand, you can just drag along. You can zoom in to read the text, to see where you are, and zoom in even more. So another thing to navigate throughout this thing is click on the outline. You can go, it will move to the team. And then when you go to step 2, it will immediately take you to define the challenges, which is the step 2. So when we go back here, you can, in some locations, I see somebody else is visiting. Very nice, you're joining. You can, for example, type here your name from the Netherlands. And then I can drag this point to make it bigger. So, and place it where I am from, for example. So I will now undo this for the team to actually do it. During the brainstorm sessions, you might want to place sticky notes with your ideas. You can type. You can add more text, like a text box. You can add images. I want to add an image of a koala, for example. Just drag it and place it. This one was not available. And make it smaller. So you can really do a lot of things. You can work together in it. So I would we want to encourage you to do that. There's like a lot of tips and things how to go about. If you double click, there will also get a mural, and there will be blue boxes popping up, which give you explanation on how to do things. So each team has their own mural, and your coach can also go in there. The timings are an indication, see what is best. If there are things that you can have to do or that are important things to note, it is in a yellow box. And at the end, if you follow it, you will have hopefully a very good, clear description. And it will guide you also through the criteria where the jury is judging you on. So I hope this is clear. Let us know if you have big questions about it, if things are not working, and we will try our best to help you. And enjoy the hacking. I hope you will have a great time.
Thanks, Karin. That's a really nice overview of the mural. I think as teams are able to open their own murals and look at the different activities and start interacting with it, it'll provide a really nice tool. But we also want to say it provides us as the coaches and our jury members a really nice overview of what you have done and the process you're going through. So be sure that you are filling out your mural because it is part of our judging criteria. So I think with that, we're ready to wrap up. I would like to give a big thank you to our keynote speakers, our organizing team, our supporting partners, and our incredible team of coaches, experts, and jury members that will make this hackathon a success. We have a team assembled, including academic staff, international agencies, governmental advisors, NGOs, and entrepreneurs to support and challenge our teams through this process. So participants, now it is time for you to open the hackathon platform and go to your team workroom to meet your team. So follow the steps that Karin just showed you, and you should have access to a team and the Jitsi room and the mural. The coaches will also be coming around within the next 30 to 40 minutes to meet everyone and answer any questions that you have, and kind of create a communication plan for the next week. So with that, we will close our opening session, and thank you all for attending, and we wish you a great week ahead. So good luck and happy hacking.